Hello everyone. Today we're diving into 2D arrays, also known as multi-dimensional arrays. This is part 1 of our series. In this video, we'll cover 4 important topics. First, what is a 2D array? Second, we'll explore memory layout and addresses to understand how arrays are stored. Third, we'll learn about initialization and access, which means how to create and use 2D arrays. Finally, we'll look at traversal patterns, which are different ways to move through the array elements. Let's get started. Now let's understand what a 2D array is. A 2D array is a collection of elements arranged in rows and columns. Think of it as a table or grid structure, just like a spreadsheet. Here's an example with 3 rows and 4 columns. Notice how the columns are labeled col 0, col 1, col 2, and col 3 at the top. The rows are labeled row 0, row 1, and row 2 on the left side. The grid contains numbers from 1 to 12, arranged in this table format. Let's look at the key points. First, a 2D array contains rows and columns. Second, each element is accessed using 2 indices, row and column, written as row in brackets, column in brackets. Third, the total number of elements equals rows times columns. In this example, 3 times 4 equals 12 elements. This grid structure makes it easy to organize related data. Now let's learn how to declare a 2D array. The syntax is simple. You write the data type, followed by the array name, then 2 sets of brackets. The first bracket contains the number of rows, and the second bracket contains the number of columns. Let's look at example 1, an integer 2D array. We write in ARR, first bracket containing 3 and second bracket containing 4. This creates a 2D array with 3 rows and 4 columns, which can store integer values. Example 2 shows a character 2D array. We write char grid, first bracket containing 5 and second bracket containing 5. This creates a 5 by 5 grid of characters. Here are the key points to remember. The first bracket represents rows. The second bracket represents columns. And the size must be known at declaration time, meaning you need to specify the dimensions when you create the array. Now let's understand how 2D arrays are stored in memory. 2D arrays are stored in contiguous memory locations, which means all elements are placed one after another in a continuous block. They're stored in row major order, meaning row by row. Let's look at an example. We have an ARR with 3 rows and 4 columns, containing values 1 through 12. On the left, you can see the visual representation of the 2D array. It's a table with row labels and column labels, showing all the values arranged in 3 rows and 4 columns. On the right, you can see the memory addresses, which shows how it's actually stored in the computer's memory. Let's start with row 0. The addresses are 1000, 1004, 1008, and 1012. The values stored there are 1, 2, 3, and 4. The indices are 0, 0, then 0, 1, then 0, 2, and 0, 3. Similarly, row 1 and row 2 is stored in contiguous memory locations. Here are the key points. Each integer takes 4 bytes of memory. Elements are stored continuously row by row. The address difference between consecutive elements is 4 bytes. And there's a formula to find any element's address. Base address plus I times columns plus j times size. This formula helps us calculate the exact memory location of any element. Now let's learn different ways to initialize a 2D array. There are 4 common methods. Method 1 is at declaration. We write in ARR, first bracket containing 2 and second bracket containing 3 equals, then use double curly braces. The first set contains 1, 2, 3, and the second set contains 4, 5, 6. This creates a 2 by 3 array with those values. Method 2 is without inner braces. We can skip the inner braces and just write all values in order, 1, 2, 3, 4, 5, 6. The compiler automatically fills them row by row. The result is the same as method 1. Method 3 is using loops. We first declare the array, then use nested for loops. The outer loop goes through rows, and the inner loop goes through columns. We calculate each value using the formula I times 3 plus j plus 1. This also creates the same array. Method 4 is partial initialization. We can provide fewer values than needed. For example, we give only 1 and 2 for the first row and only 4 for the second row. The remaining elements are automatically set to 0, shown in green. This is very useful when you want to initialize most elements to 0. Now let's learn how to access elements in a 2D array, which means reading and writing values. The syntax is simple: array name, then row index in brackets, then column index in brackets. Let's use an example array with 3 rows and 3 columns, containing values 1 through 9. You can see the grid with row labels on the left and column labels on top. For reading elements, we use the same bracket notation. If we write int value equals ARR with first bracket containing 1 and second bracket containing 2, this reads the element at row 1, column 2, which is 6. For writing elements, we use an assignment statement. If we write ARR, first bracket containing 1 and second bracket containing 2 equals 10, this changes the value 6 to 10. Here are the key points to remember. Index starts from 0, not 1. The first index is always the row, and the second index is the column. When we write ARRIJ, it means the ith row and jth column. Valid row index goes from 0 to rows -1. And valid column index goes from 0 to columns -1. Understanding these rules helps you avoid errors. Now let's learn about traversal patterns, which means how to iterate through all elements of a 2D array. We'll start with row-wise traversal. Here's our example array with 3 rows and 3 columns, containing values 1 through 9. To traverse it row-wise, we use nested loops, which means a loop inside another loop. Look at the code. The outer for loop uses variable I to go from 0 to less than 3, which controls the rows. Inside it, the inner for loop uses variable j to go from 0 to less than 3, which controls the columns. For each combination of I and j, we print ARRIJ. Let's see how it works step by step. When I equals 0 and j equals 0, it prints 1. Then I stays 0, j becomes 1, and it prints 2. Once both for loops complete, it prints output 1 through 9. Here are the key points. Use nested loops, a loop inside a loop. The outer loop controls rows. The inner loop controls columns. And the time complexity is big O of rows times columns, because we visit every single element once. Let's explore common use cases and interview problems for 2D arrays. Understanding these applications helps you see why 2D arrays are so important. First, matrix operations. 2D arrays are perfect for matrix addition, subtraction, and multiplication. You can also perform matrix transpose and rotation operations. Second, image processing. Each pixel in an image can be represented as an array element. This makes it easy to apply image filters and transformations. Third, game development. A chessboard is an 8x8 grid. Tic-tac-toe uses a 3x3 grid. Many game maps and levels are also built using 2D arrays. Fourth, data tables. Spreadsheets and database query results are naturally represented as 2D arrays with rows and columns of data. Thank you so much for watching this tutorial. I hope you found this lesson helpful and easy to understand. If you enjoyed this video, please hit the like button. It really helps the channel grow. Don't forget to subscribe to the channel for more beginner-friendly programming tutorials and helpful tips. Feel free to comment your questions or thoughts below. I love hearing from you, and I try to respond to every comment. And don't forget to hit the bell icon so you get notified whenever I upload new videos. See you in the next lesson.